And we're off to the algebra problems. All right. So if Jackie has two solutions that are 2% and 12% sulfuric acid by volume, respectively, if these solutions are mixed in appropriate quantities to produce 60 liters of a solution that is 5% sulfuric acid, how many liters of the 2% solution will be required? Okay, so we have a mixture problem where we know that we have a 2% solution. We don't know how much of it we have. We have A liters. And if we add a 12% solution with some B liters, then we're going to end up with a 5% solution that has 60 liters within it. And of course, we also know that A plus B is equal to 60. Okay? So how do we solve this problem? Well, for our second equation, let's go ahead and multiply through by 100 just to clean it up, so that we have 2a plus 12b is equal to 5 times 60. Next, what's the question asking for? It's asking us for how many liters of the 2% solution. So we want to solve for our a variable. Okay, since we're going to solve for our a variable, we're going to take this first equation, a plus b equals 60. Let's move it down here, and let's simplify it. Let's solve for b. Okay, if we solve for b, we know that b is equal to 60 minus a. And we're going to use this and plug it in for our b value right here. So let's go ahead and do that. So we have 2 times a plus 12 times 60 minus a is equal to 300. 5 times 60 is 300. Next, we can go ahead and divide by 2, and we'll be left with a plus 6 times 60 minus a is equal to 150. And then we can distribute, and we would have a plus 360 minus 6a is equal to 150. Now we can combine like terms and move the 360 over. And once we do that, we're going to have negative 5a is equal to negative 210. And then we can divide by negative 5 to have that a is equal to 42. So how many liters of the 2% solution will be required? It's going to be required that we have 42 liters of the 2% solution. If Jake loses 8 pounds, he will weigh twice as much as his sister. Together, they now weigh 278 pounds. What is Jake's present weight in pounds? Okay, so we know that if Jake lost 8 pounds, he would be twice as heavy as his sister. We also know currently that Jake plus his sister, their weight added together, is going to be 278 pounds. Okay, for this question, we're asked to solve for Jake's present weight, so we want to solve for J. So what I'm going to do for this problem, I'm going to solve it a little bit differently than the last one, just so we see some variety here. I'm going to take this first equation and let's rearrange it such that our two variables are on the same side. So I'm going to do, we have J minus 2s is equal to positive 8. And then for this equation, I'm going to scale it up by a factor of 2. And you'll see why I'm doing this just in a moment. So we have 2j plus 2s is going to be equal to what? We want to double 278. And whenever we do that, we're going to get 556. All right, now I have my two equations. And the reason I did this is because I want to cancel out my s's and just leave me with j so I can solve for Jake's weight. Whenever I combine these two equations, I'm just adding them together. J plus 2j is 3j. And then 2s plus, or negative 2s plus 2s cancels out by design. And then 8 plus 556 is going to be 564 pounds. So lastly, I just need to take 564 and divide it by 3 in order to solve for j. 3 goes into 5 one time with 2 left over. 3 goes into 26 8 times with 2 left over. And 3 goes into 24 8 times evenly. So Jake's weight is 188 pounds at this present moment. A certain experimental mathematics program was tried out in 2 classes in each of 32 elementary schools and involved 37 teachers. Each of the classes had 1 teacher, and each of the teachers taught at least 1, but not more than 3 of the classes. If the number of teachers who taught 3 classes is n, then the least and greatest possible values of n, respectively, are what? Okay, so let's write down some info. We're told that 2 classes in each of our 32 elementary schools taught this program. So that means we have a total of 64 classes with 37 teachers. All right, and we're asked to find the number of teachers which taught 3 classes. We're asked to find the minimum value and the maximum value. So looking to my answer choices, I see that 0 appears as a minimum. So let's check 0. Do we not even need any teachers to teach 3 classes, or is it needed? So let's assume all of our teachers taught 2 classes. If all of our teachers taught 2 classes, then we would have 37 teachers times 2, and we would get 74. So this tells me that there is no need for any teacher to teach this class 3 times. They may, but there's no need for it. Therefore, the minimum value is 0. So I can go ahead and mark out answer choices C, D, and E. Now let us think about the maximum value. Again, let's use our answer choices. We know the maximum is either going to be 13 or 14. So let's change colors. Let's assume the maximum is 13. This means that 13 teachers taught 3 of the classes. If 13 teachers taught 3 of the classes, that's a total of 39 classes that are taught. That's 39 classes taught. And we used 13 of our teachers. Okay? If we use 13 of our teachers, then let's subtract 13 from our amount of teachers. So that means we have 24 teachers left. Let's say each of these teachers taught just 1 class, the bare minimum. Okay, we would add 24 to this, as those 24 teachers taught 1 class. And whenever we sum this, we get that we have a total of 63 classes. However, we're told that we have 64 classes, but that's okay. That implies that 13 teachers taught 3 classes, 1 teacher taught 2 classes, and then the remaining 23 teachers taught 1 class. And that would give us the total of the 64 classes. So this is a valid way, but is 13 the maximum, or is 14? So let's clear this up just a little bit, and let's think about it if we had 14 as the maximum instead. So if 14 was the maximum, then 14 times 3 would be 42. So we have 42 classes that are taught by these 14 teachers teaching 3 of the classes. And that tells me that we have a remaining, we subtract the 14 teachers, we have a remaining 23 teachers. So if each of these 23 teachers taught the minimum of 1 class, then we would add 23 classes, and we see that we have 65. Well, this is too many. We have 1 more class that's accounted for. So 14 is not our maximum, 13 is our maximum. So our answer for this question is going to be answer choice A, a minimum of 0 and a maximum of 13. For the positive numbers n plus 1, n plus 2, n plus 4, and n plus 8, the mean is how much greater than the median. So let's write out these numbers. We have n plus 1, n plus 2, n plus 4, and n plus 8. And we want to compare the mean to the median. So what is the median? That's going to be easier to find. The median's the middle number. So the middle number is clearly n plus 2. So our median is n plus 2. So what's our mean going to be? Well, the mean is adding up all of these values and dividing by how many there are. So there's 5 values, so we're going to divide by 5. But whenever we add them all up, what do we have? Well, n plus n plus n plus n plus n would be 5n. And 1 plus 2 plus 4 plus 8 is 15. 5n plus 15 divided by 5 is n plus 3. So the mean is 1 more than the median. So our answer here is answer choice B. The present ratio of students to teachers at a certain school is 30:1. If the student enrollment were to increase by 50 students and the number of teachers were to increase by 5, the ratio would change to be 25:1. What is the present number of teachers? Okay, so we have some student-teacher ratio that is 30:1. Okay, and we're told that our ratio may change. Of course, this 30:1 is really just some 30x over some 1x, whereas we don't necessarily have 30 students and 1 teacher. We could have 60 students and 2 teachers, right? So that's why this x is here. We're told that our ratio changes a little bit. It changes to 25:1 whenever we increase our student population by 50. So that would be a 30x, our original, plus 50. And our teacher population increases by 5. So that would be a 1x plus 5. Okay? So to solve for x, we just need to cross multiply. 25 times 1x is 25x. And 25 times 5 is 125. And then we have 1 times 30x, which is 30x, and 1 times 50, which is 50. Now we just need to combine like terms and solve. So I can move my 25x over to have 5x, and I can move my 50 over to have 75. Then I can divide by 5 to see that x is equal to 15. If x is equal to 15, and the question is, what is the present number of teachers? Well, my teachers represents this 1x. So if x is 15, 15 times 1 is 15, so the present number of teachers is 15. So 4 extra large sandwiches of exactly the same size were ordered for m students, where m is greater than 4. 3 of the sandwiches were evenly divided among the students, and since 4 students did not want any of the 4th sandwich, it was evenly divided among the remaining students. If Carol ate 1 piece from each of the 4 sandwiches, the amount of sandwich that she ate would be what fraction of a whole extra large sandwich? All right, Carol. So what did Carol eat? Well, firstly, the first 3 sandwiches were divided among m students. And then the last sandwich was divided among m minus 4 students. And Carol ate a piece of each sandwich, so we would just add these 2 fractions together. So to add these 2 fractions together, we need to find a common denominator. So let's multiply this first fraction by m minus 4 in both our numerator and our denominator. And let's multiply this second fraction by m in our numerator and our denominator. Once we do that, we have 3 times m minus 4 over m times m minus 4, and we will add that to 1 times m is m over m times m minus 4. Next, let's distribute the numerator in our first fraction to get 3m, oops, wrote a 4, 3m minus 12, and then we would add the numerator of our second fraction and put it all over the same denominator of m times m minus 4. Lastly, we combine like terms. 3m plus m is 4m. So let's do that here. And now we have our answer. So we can see our answer is answer choice E, Carol 8, 4m minus 12 over m times m minus 4 parts of a single sandwich. Excellent. Which of the following equations has 1 plus the square root of 2 as one of its roots? All right. So for this problem, I think it would be best to use the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, and all of this is over 2 times a. Now we want the root to be 1 plus the square root of 2. So when all said and done, we want this to equal 1 plus or minus the square root of 2. Of course, we're just looking for the positive root 2 root, but I'm going to leave it as plus and minus as we have a plus and minus here. So using this as a reference point, I'm now going to look over to my answer choices. Okay, we want this first digit to be positive. That means my b value must be negative, as our quadratic formula starts with a negative b. And we want this output to be a positive value, so our b value needs to be negative. So we can go ahead and eliminate answer choices A, C, A and C. So we're left with B, D, and E. Also notice that for all of our answer choices, our A value, the coefficient in front of our x squared, is 1. So let's just go ahead and get rid of these A's in our formula because we know they're just going to be 1, so they're not going to impact anything. All right. So now we have negative b plus or minus the square root of b squared minus 4c all over 2. Okay. So again, we see that we're going to be dividing by 2, and we want our output to be 1 plus or minus the square root of 2. So let's multiply this numerator by 2. Let's multiply this by 2 over 2. And what would we get if we did this? So let's just go out to the side so that we can recognize that 1 plus or minus the square root of 2, if we multiply this by the fraction 2 over 2 so that nothing really changes, then what are we left with? We would be left with 2 plus or minus 2 square roots of 2 over 2. So this is what we want our quadratic formula to look like. 2 plus or minus 2 square roots of 2 over 2. Let's also just note that 2 square roots of 2 could be written as the square root of 8. And since everything here is under the radical, it might be easier to think of it this way. So now we can see that our b value needs to be negative 2. And so we can go ahead and eliminate answer choice E. So now we're left with answer choice B or D, where the only difference is our C value positive 1 or negative 1? Well, we want our output, we want what's within our square root to be an 8. So what could that be? We already know that B is going to be negative 2. So under this radical, we can change this b squared to just be a 4, as negative 2 squared is going to be positive 4. And we want 4 minus 4c to give me a positive 8. So if c was 1, we would have 0. We don't want that. So c needs to be negative 1, such that whenever we finish this formula, we will have this output. And so if c must be negative 1, then my answer for this problem is going to be answer choice D, x squared minus 2x minus 1 equals 0, will have a root of 1 plus the square root of 2. At a certain fruit stand, the price of each apple is 40 cents and the price of each orange is 60 cents. Mary selects a total of 10 apples and oranges from the fruit stand, and the average price of the 10 pieces of fruit is 56 cents. How many oranges must Mary put back so that the average price of the pieces of fruit that she keeps is 52 cents? All right, so we know that the apples cost 40 cents and the oranges cost 60 cents, and all in all, the average is 56 cents. So the total of 10 pieces of fruit times 56 cents would be the total price. We of course also know that apples plus oranges is equal to 10. So if we're going to solve this system of equation, I can first divide everything by 10 and be left with 4 apples plus 6 times oranges equals 56. Now I'm going to scale this first statement up by a factor of 4. If I do that, then I have 4a plus 4r is equal to 40. And now I can subtract these two equations to leave me with 2 times oranges is equal to 16. Therefore, my orange number is equal to 8. So this tells me that I'm starting with 8 oranges and 2 apples. So let's move this to the side, okay? So we're starting with 8 oranges and 2 apples. What else does the question tell me? Well, so since I'm starting with 2 apples, I have 2 apples that are 40 cents each, and I want to know how many oranges do I need to buy at 60 cents such that my average price is 52 cents. So 2 plus the number of oranges equals 52 cents, so times 52. So now let's solve this system such that 2 times 40 is 80 plus 60r is equal to, well, 2 times 52 is 104r plus, or I'm sorry, 104 by itself plus 52r. Next, we can just combine like terms. We can move the 80 over and the 52r over to have 8r is equal to 24. Therefore, r is equal to 3. So the question says, how many oranges must Mary put back? If I'm going from 8 to 3, then that means I'm putting back 5 oranges, answer choice E. In order to complete a reading assignment on time, Terry planned to read 90 pages per day. However, she only read 75 pages per day at first, leaving 690 pages to be read during the last 6 days before the assignment was to be completed. How many days in all did Terry have to complete the assignment on time? All right, so we know that the number of days that Terry had to complete her assignment would be equal to the page count divided by 90, as that's what she was expecting to read each day. However, what is our page count? Well, our page count would be equal to 75 times the number of days in which she read 75 pages plus the remaining 690 pages. And we also know that the total amount of time it took would be n plus 6. So the number of days is going to be n plus 6, and this will equal our page count of 75n plus 690 divided by 90. So now let's just solve this equation. We can multiply both sides by 90. When we do that, we will have 90n plus 540 is equal to 75n plus 690. Then we can combine like terms, and we'll be left with 15n equals 150. Therefore, n is equal to 10. Notice that 10 isn't an answer choice, but again, the total number of days is n plus 6, and 10 plus 6 is 16. Our answer is choice B. The graph of which of the following equations is a straight line that is parallel to the line in the figure above? Okay, so it's important for us to know that parallel lines have the same slope. So we want to know the slope of this given line. So let's look at 2 points on this line. We can see we have a point here. This point is at -3, 0. And we also have a y-intercept here, which is at 0, 2. So our slope is our rise over our run. So we rose 2 units and ran 3 units. So the slope of this line is equal to positive 2/3. So out of our answer choices, we want to find a slope that is going to be positive 2/3. So we have to kind of change all of these equations into y-intercept form, into y equals mx plus b form, and we want our slope m to be 2/3. So for statement A, for answer choice A, if we move the 2x over, then divide by 3, we would have 2/3. So A looks good. For B, let's just double check. B, if we move the 2x over, it would be negative, so that wouldn't work. For the same reason, C wouldn't work. And for D and E, notice that we have a 3x, and so that won't work for either of those. So our answer here is answer choice A. An object thrown directly upward is at a height of h feet after t seconds, where h equals -16 times t minus 3 squared plus 150. At what height in feet is the object 2 seconds after it reaches its maximum height? Okay, so let's draw a graph for this. So what you need to know for this problem is you need to know that the function is given to us in vertex form. So we know the vertex of this parabola is going to be at 3 and 150. So here is our vertex. That's where our maximum height is. And so our parabola looks, something like this. Picture is not the greatest, I know, but it looks something like this. And we want to know the height in feet of the object 2 seconds after it reaches its maximum height. Well, its maximum height is its vertex at 3 seconds. So 2 seconds later would be at 5 seconds. So all we're going to do is plug in 5 for t. So our height is equal to -16 times 5 minus 3 squared plus 150. So this is -16 times 2 squared, which is 4, plus 150. This is -64 plus 150, and this is 86. So our answer is choice B. Which of the following is equivalent to the pair of inequalities x plus 6 is greater than 10 and x minus 3 is less than 5? Okay, so let's rewrite these inequalities. So we have x plus 6 is greater than 10, And if we solve for x in this, we would have x is greater than 4. Similarly, with our second inequality, we have x minus 3 is less than 5. And if we solve for x, we get x is less than 8. Putting these two inequalities together, we have 4 is less than x, which is less than 8. Therefore, our answer is answer choice D. At his regular hourly rate, Don had estimated that the labor cost of a repair job would be $336, and he was paid that amount. However, the job took 4 hours longer than he had estimated, and consequently, his rate was $2 per hour less than normal. What was the time Don had estimated for the job in hours? So we know that Don's rate times the number of hours he expected to work would equal $336. However, Don seems like a pretty nice guy in that the amount of hours it took for the job was 4 more than expected, and as a consequence, the rate in which he was paid was $2 per hour less, but he still took the $336. So now let's solve this systems of equations. We can FOIL this to have h times r is, we'll have rh, then h times negative 2 minus 2h plus 4r minus 8 is equal to 336. Using our first equation here, we see that r times h is equal to 336. So let's plug that in. We have 336 minus 2h plus 4r minus 8 is equal to 336. Next, let's combine all our like terms. If we subtract the 336, that would be 0, and then if we add the 8, we would have 8. So all said and done, we have minus 2h plus 4r is equal to 8. Next, let's divide both sides by negative 2, and that will leave us with h minus 2r is equal to negative 4. All right, the question wants us to solve for the estimated amount of hours for the job. Therefore, let's take this first equation and let's solve for r so that we can plug the value in for it down here. So we see that r would be equal to 336 over h. So now let's plug this value in for r. Before we do that, let's take all this work and shrink it down and move it over to the side to give us some more room. Okay, so plugging in the value of 336 over h for r, we'd be left with h minus 2 times r, which is 336 over h, and we know that this is equal to negative 4. Next, let's multiply both sides by an h, and that would leave us with h squared minus 2 times 336 is 672, and it would equal negative 4h. Next, let's put everything on the same side so that we have h squared plus 4h minus 672 is equal to 0. And lastly, let's factor this equation. So factoring this seems a little bit hard as I don't know my factors of 672 off the top of my head. However, I do know that 25 squared is 625, so we're going to be in the 20s. Also, just by using my answer choices, I'm going to expect 28 or 24 to be a factor. I'm more comfortable with 24, so let's see if 24 is a factor. So I have 672, and I want to see if 24 divides into it evenly. 24 goes into 67 twice, as 2 times 24 is 48. You subtract and you get 19 and bring down your 2. And 24 times 8 is 192. So I can see I have my two factors of 24 and 28, such that this equation factors to give me h minus 24 times h plus 28, and this equals 0. So I know my two solutions are h equals 24 and negative 28. Of course, you can't have a negative hourly amount, so our answer is going to be answer choice B. Don estimated this work to be 24 hours. Fantastic. To mail a package, the rate is X cents for the first pound and Y cents for each additional pound, where X is greater than Y. Two packages weighing 3 pounds and 5 pounds respectively can be mailed separately or combined as one single package. Which method is cheaper and how much money would be saved? Okay, so if you have a 3-pound package, then and you were to mail it, the first pound would be X cents, and then the next 2 pounds would be Y cents. If you had a 5-pound package, the first pound would cost X cents, and the remaining 4 would cost Y cents. So if you mailed the two separately, it would cost a total of 2x plus 6y. However, if you mailed the package together, then you would have a single package which weighs 8 pounds. And we know that the first pound is X cents, and the remaining 7 pounds would cost Y cents. So the difference here, so what's the difference in cost? Well, just subtract X plus 7y, and you'd be left with X minus y. So the difference is X minus y. And of course, the combined option is cheaper, as we know that X is greater than y. So our answer is going to be answer choice A. Combined is cheaper, and you'd have a savings of X minus y cents. Which of the following inequalities is an algebraic expression for the shaded part of the number line above? All right, let's notice that our number line is bound from -5 to 3 inclusive. And from this, I can already eliminate answer choices A and B, as A would be bound from -3 to 3 and B would be bound from -5 to 5. Next, let me just plug in one of our extremes. Let me plug in -5 in for X for answer choices C, D, and E. If I plug in -5, I would have -5 minus 2. This is, the absolute value of this is 7, and 7 is not less than 3, so C is not valid. For D, I would have the absolute value of -5 minus 1. -5 minus 1 is -6. The absolute value of this is 6, and 6 is not less than or equal to 4, so D is not valid. That leaves answer choice E, but let's go ahead and check it. The absolute value of -5 plus 1 is 4, and 4 is less than or equal to 4, so answer choice E is the choice here. A border of uniform width is placed around a rectangular photograph that measures 8 by 10 inches. If the area of the border is 144 square inches, what is the width of the border in inches? Okay, so I have some picture here. I have an 8 by 10 picture, and I have a uniform border that surrounds it. Okay, let's pretend this border is uniform. I know my picture is 8 by 10. And we have some border that's uniform, so this is X. This would also be X. All of these distances have a length of X. That's our unknown. We're told that the area of the border is 144. How could we find the area of the border? So the area of our border is, of course, going to be our full length, which would be 8 plus 2x, times our full width, which is 10 plus 2x, and then we would want to subtract the area of the photograph. The photograph is 8 by 10, so we would subtract 80, and this would leave us with the area of our border, which we know is 144. Next, we can just solve the equation. So let's distribute. We have 8 times 10 is 80. 8 times 2x is going to be a plus 16x. 2x times 10 is going to be a plus 20x. Then 2x times 2x is going to be a plus 4x squared. And then we have our minus 80 equals 144. Next, let's combine like terms. Our 80 and our minus 80 will cancel. And then let's rearrange such that we have 4x squared plus 36x is going to equal 144. Next, we can divide everything by 4. Whenever we do that, we're going to have x squared plus 9x is equal to, let's go out to the side, 144 divided by 4. Put a 3, carry a 2, there's a 6, equals 36. Next, we can subtract 36 from both sides and set our equation equal to 0. And then we can just factor this equation. What two things multiply to give me 36 or negative 36 and sum to be 9? Well, I know that 3 and 12 multiply to give me 36. So I'm going to have an x plus 12 times an x minus 3, and this will be 0. And this tells me that my solutions are positive 3 and negative 12. Obviously, you can't have a negative length for your border, so that tells me that my border is 3 inches, answer choice A. In a room filled with 7 people, 4 people have exactly 1 sibling, and 3 people have exactly 2 siblings. If 2 individuals are selected at random, what is the probability that those 2 people are not siblings? Okay, so let's draw a picture to see what's going on here. We have 7 people in a room. 1, 2, 3, 4, 5, 6, 7. So we have 7 people in this room. And we know that 4 of them have exactly 1 sibling. So these 2 could be siblings and these 2 could be siblings. And then next we're told that the remaining 3 people are all siblings with each other, as each have 2 siblings. So this is kind of what our graph looks like. And we're asked to find the probability that if 2 people are selected, what's the probability that they are not siblings? So we kind of have 2 things that could happen here. For our first person selected, what if it's one of these 4 people? Because they all have the same feature of only having 1 sibling in the room, so they would have the same probability no matter what. If one of these 4 were selected at first, that's a chance of 4/7 of that happening. Then what's the probability that the other person selected, the second person, would not be a sibling? Well, that probability would be 5 out of 6. As if, let's say, this first person was selected, the probability that the second person is not their sibling is 1, 2, 3, 4, 5 out of the total of 6. Okay, so this would be our first probability. Our second probability would be if our first person selected came from this group. If our first person selected came from this group, that is a 3 out of 7 chance of happening. And we're looking for the probability that the second person selected is not their sibling. Well, that would be a probability of 4/6. As again, there's 4 people remaining, which are not their siblings, and there's a total of 6 people remaining. Okay, so these probabilities multiply out to be 20 40-seconds and 12 40-seconds respectively. So now we just need to add these 2 probabilities together. If we add these together, we would get 32 40-seconds, and this simplifies to 16/21. So answer choice E is our answer here.